Hello there. Let's calculate some sum of squared errors. Put the x's and y's into their list. Now I'm also going to simultaneously graph this so I can see what's going on. I need different scales here, so my x's are going by 1s, my y's are going by 10s, and plot the points. Again, exceedingly difficult to do this well on an iPad. It looks like from this that this is a strong, perhaps very strong, positive correlation. And we want the linear regression. So I need to go in and type this data into my list 1, list 2, and then do a linear regression of that. Oh, look at that. Integer 7x plus 22, almost as if that were by design. Okay, let's draw that in there. Again, exceedingly difficult to do well. But I can already see that I have these prediction points. That my blue point down here is below the line. The line thinks it's going to be a bit higher, so I want this next column to be my predictions. And my predictions are based off of that equation, so I can type that equation in here. It's going to be 7x, and the x's are here in list 1. So I go up to the top and I define that as 7 times list 1 plus 22. Now this is getting my predicted value. Okay, so let's type that in. And this is where the line thinks this x value of 1 should be for a y value. So it should be up here at 29. It's actually down there at 27. It's below average. And our next column is going to be that difference there. The so-called residual, which is your actual minus your observed, or list 2 minus list 3. So again, notice that these points that are below the line, this one's actually spot on here, these points that are below the line have negative residuals, and this one that's above the line has a positive residual. It's above average. That's a good thing. Let's draw on a visual for these residuals. It is a line that goes vertically. Kind of smudged there. The red ones are all the ones that are below, and the green ones above. And our last column over here is going to be the residual squared. And that's simply the previous column, list 4, squared. And graphically what's going on here is we're taking these vertical lengths and extending them out, turning them into little squares. And even though we got this really big one up here, this line here, the linear regression, actually makes the sum of all of these squared errors as small as possible. This is the best line. No other line is going to deal with this problem here as well. That one sort of stood out anyways, went down below it. We have one last thing to do. Of course, we need the sum of squared errors, so I need to add up this column. So I go into my list, my calculator, and over to math and sum. Sum of list 5, which is 144. That's pretty gross. Okay, that's our answer. I won't be asking for this picture here. It's nice to know what you're doing. It helps organize each of these steps, but I do want to see all of these steps in the table. When the lists get really long, you don't need to show all of these numbers, but you do need to show the headers, the process of what you're doing. All right, character and scholarship for life.